Hello friends, I welcome you all in this session. In this session we will discuss about couple of project selection techniques. In previous session we discussed about BCG matrix and McKenzie matrix. So in this session let us discuss something called space diagram. Space diagram is also one of the project selection or project evaluation methods wherein we will evaluate different projects and products and we will take appropriate strategy whether we should continue with those products or not. So it's a management tool to analyze and a company and decide its future strategy, isn't it? As I said, whether you want to continue with that project or you want to discontinue it, right? So you need to look at 4 points in this space diagram: financial strength and competitive advantage. So financial strength of your organization and how good you are at competitive advantages compared to other competitors. So these two are internal to your organization, but if you look at environmental stability and industry attractiveness, these are external to the organization. So we will see these factors, and according to a particular situation we will take an appropriate decision. For example, if your financial strength is good, let us say on a let us say 10-point scale, if it is 4 and industry attractiveness is also 5, right. So government has given several incentives and government has given several facilities. So industry attractiveness is very good. So this is a situation where you should be very aggressive. So adopt aggressive strategy. But if let us say industry attractiveness is, let us say this, let us say competitive advantage is this, for example, and financial strength is this, then it is always suggested to go for conservative strategy. You need not be aggressive, but you need to be conservative. If industry attractiveness is high, but financial strength or let us say the environment stability is low, then you need to go for competitive strategy, not the conservative one. And if this is the situation, for example, environment stability low, competitive advantage low, then go for defensive. So you can have, let us say, these two are opposite to each other, right? Aggressive strategy and defensive strategy. You have got competitive strategy in this case and you have got conservative strategy. So depending upon your situation in a particular quadrant, you should adopt an appropriate strategy. Now what is the meaning of financial strength? Financial strength means how good returns you are getting on investments, how quickly you are able to raise funds whenever there is a need. For example, if there is a need of financial if you need some money, then you may not, in fact you should not start negotiating with the banks at that particular point of time. If you are having good relationship with the banks, then you can get funds easily and that would be a plus point for your organization. How good you are at liquidity, do you have lots of cash? If it is, then that would be a financial strength. Working capital expenditure, if you are able to meet these expenditure smoothly, then you are good at financial strength. If you look at competitive advantage, then there are points like market share, capacity utilization, location advantage. This is very good point as far as competitive advantage is concerned. You can make lots of money if your business is at a particular location. right. So, brand image, product quality, all these things come under competitive advantage. So, financial strength and competitive advantage, and these two are what? These two are internal to your organization. But if you look at environmental stability and industry attractiveness, they are external to your organization, right. So, we will call it external dimensions, right. So, environmental stability, what is the demand elasticity? I hope all of you would be knowing demand elasticity. There are certain products for which demand would be very much inelastic. When I say inelastic demand means you cannot postpone the purchasing of those products. For example, medicines, for example, salt and so on, right. So, these are a couple of things you should look at under this particular dimension, environmental stability. How easy to exit from that particular business. Sometimes you get into business, but it is very difficult to come out of business because of several norms, several regulations, several rules. Industry attractiveness, it is very similar to the points which we discussed in McKinsey matrix. So, how easy to enter, what are the incentives government providing, what are growth potentials, what are profit potentials and so on. So, these are external dimensions, industry attractiveness and environmental stability. Now, after discussing this particular selection technique, space diagram, let us look at some more techniques, but before going for some more techniques, let us decide what are different criteria on which you should select a project. So, selection criteria can be tangible, can be intangible. When I say tangible, it means you can measure it either in terms of rupees or in terms of percentage growth or in terms of the rupees per year earned, or let us say loss per year and so on. So, you can measure them, but on the other hand you have got some intangible criteria. You cannot measure directly, but you need to have some subjective scale, right. For example, how to measure let us say image of the company, right. So, you can have some let us say 10-point scale, and then you can ask questions to the customers, and then you say this is the image of the company, right. So, you have got intangibles and you have got tangible criteria, right. So, in tangible again many times you have got, you can have incommensurate and you can have commensurate sub criteria under tangible criterion, right. So, incommensurate, let us say rupees for investment and years for payback period. So, you can have different units, but you may also have same units. So, we would be calling them as commensurate sub criteria, right. When you have projects, let us say if there are several projects, then you can have two types of sets. First is dominance project, and the other one is non-dominance or Pareto optimal set. When I say dominance means out of 10 projects there is one clear winner which you would be taking up for your organization. But when you say non-dominance or Pareto optimal set, you have got several projects which would be giving you similar profit or similar IRR or similar payback period, right. So, let us look at what is there in next slide. So, this is the slide wherein you have got non-dominance and Pareto optimal set. So, let us say you are selecting projects on the basis of two criteria, net present value and IRR, right, and let us say there are 8 projects. So, you have got let us say P1, P2, P3, P4, 5, 6, 7 and 8. So, if you look at For example, P2 project. Now in P2 project, if you look at, this is your return, this is your NPV. Had there been only one criterion that is return, you would have definitely chosen this. So out of these two criteria, P2 is good on this particular criterion, this one, but not so good at NPV. If you look at P7 project, it's very good at NPV. NPV is this, but return is only this much. Okay. So either you select P2 or you select P7. On P2 you will get good returns, but NPV is low. Here NPV is good, but not so good returns, right. On the other hand, if you look at P1, P6 and P8. So P1 this much return, this much NPV, P6 this much return, this much NPV, and for P8 this much return and this much NPV. Now this is known as efficient frontier. So either you select P1, P6 and P8, they all are equally good projects, right. So you would be getting, let us say if you select P1, this much return and this much NPV, and this would be as good as selecting P8 this with this much returns and this much NPV, right. So this is in this case, this is a clear winner if you take returns as criterion, right, and these are efficient frontier or Pareto optimal set. You can select any one of these, right. So let us look at a couple of other selection methods. This is the first selection method wherein you have got dominance project. Out of several projects, there would be one clear winner, one clear project which would be dominating other projects, and it is unweighted. We will not give different weightages to different criteria. So let us look at, there are 4 projects. You get alpha project, beta project, gamma project and delta project, alpha, beta, gamma and delta. And what are the selection criteria? The selection criteria are cost, profit potential, time to market and development risk. So what would be the cost of the project alpha, how profitable that project would be, how much time it will take to launch in the market, and what are the risks involved in this project alpha. So if you look at cost is very high in this, while profit potential is very low as far as alpha project is concerned. Time to market is medium, it does not take much time, right, it is quite medium, and development risk is low. Similarly, you got beta, gamma and delta. Let us look at this delta project. Cost is very low, profit potential low, time to market very high, development risk medium. Now if I ask you a question, out of these 4 projects, which project you will select if the objective is to maximize all the criteria, all these criteria? Can you think of this particular question and try to answer? The question is, out of these 4 projects, which project you will select so that all these criteria are maximized? Okay. So since we want to maximize all these criteria, if you look at this, look at this gamma project. This is high, this is high, this is high. Though we should not maximize our cost, but since your question is like that, so you are saying that you should select gamma project, right, because you want to maximize all these criteria, right. So this is one of the methods. It's an unweighted method, and clear dominance of this particular project is there. Let us look at the next model, which is simplified scoring model. It is a weighted one. So, we will take the same example of 4 projects alpha, beta, gamma and delta, but here we are assigning weights also. So, we will assign, let us say, weight is equal to 1 to cost, 2 to profit potential, 3 to time to market, and development time, development risk is 2. So, these are different weights, and again we have assigned some weightages to high, medium and low. So, let us assign this as 1, this as 2 and this as 3. Now, you want to maximize all these criteria. Which project would be the best one? Just think over it for a couple of seconds, and in fact you need to write down the values also in this particular question. So, hope you would have started solving this question. Let me give you hint. So, cost is 1, right. So, 1 into high is 3. So, this is how you should get it. So, this is 3, then profit potential is low, it means 1, profit potential here is weightage is 2. So, 1 into 2 plus time to market, this medium, right, means 2 into 3, 6 plus development risk is low, means 1 and weightage is 2. So, just add all these things, you will get a number for this. Similarly, for beta, for gamma and for delta, and the answer is beta. So, for alpha this final number is 13, for beta it is 2 into 1. So, 2 into 1, then you have got 2 into 3, sorry 2 into 2 and then 3 into 3 and 2 into 2. So, this is 19. So, the project which you would be selecting is beta, right. So, this is a weighted scoring model. Now, let us look at couple of other project selection techniques, and we'll see couple of optimization techniques, and one of the techniques is linear programming, a very widely used technique. So, let us look at what is there in linear programming. So, linear programming is basically a technique wherein we always try to maximize or minimize a function of variable, and that function is subjected to a set of constraints, and we represent those constraints in either equality form or inequality form. So, this is linear programming. I'll take up a very simple example. Let us say your organization is making mobile phones and laptops. The profit you get by selling one mobile phone is 120 rupees, and profit you get by selling one laptop is 90 rupees. And these two products, mobile phones and laptops, they go through these two processes. The first is assembly and the second one is finishing. So, in assembly process, the total time available with you is 90 hours, and in finishing process the total time available to you is 72 hours. And this 6 is nothing but the time to assemble one particular mobile. 3 is time to assemble one laptop. This 6 is time to finish one laptop, and this is time to finish one mobile. So, this question is given to you and what you have to do is you have to determine the best combination of mobile and laptops so that your profit is maximized. I hope you would have understood this particular problem. If not, you just watch this video one more time. Okay, so let us now formulate a linear program from this model, from this problem. So this is your linear programming model, and as I said, linear programming is a mathematical technique where we maximize or minimize a set of variables subject to some constraints. So here x1 is nothing but the number of mobile phones you are making, and x2 is number of laptops. So 120 x1 plus 90 x2, this is your objective function, right? You want to maximize your profit, and by selling one mobile you would be getting 120 rupees, by selling one laptop you would be getting 90 rupees. So you would like more and more profit. So you would like to produce more and more laptops and mobiles. So more of these two, x1 and x2, more is the profit, right? But you cannot do so because you have got some constraints, and the constraints are on assembly time and finishing time. So this is your constraint on assembly time. So 6x1 plus 3x2 should be equal to or less than 90. So because you have got 90 hours available in assembly process, either you consume entire 90 hours or less than that. Similarly, this is your second constraint, and this is your third non-negativity constraint. So you cannot prepare mobile and laptops in negative quantity. So this is either you don't produce mobiles and laptops, or if you produce, it would be some positive number. So this is mathematical model of the previous problem, and this is a solution to this particular model by graphical method. So I will tell you how to solve this question. This is a very simple one. So if you put x1 is equal to 0 here, then x2 would be 30. So this is the point. So at this point you have got x1 is equal to 0, x2 is equal to 30. Now when you put x2 is equal to 0 here, x1 would be 15, this point, right? So x1 is equal to 0 here, x2 is equal to 0 here, you have got x1 is equal to 15. So this point, right? If you look at second constraint, if you put x1 is equal to 0 here, when x1 is equal to 0, x2 is equal to 12, right? And when you put x2 is equal to 0 here, x1 is 24. So this area is common in these two constraints, right? And this is the direction towards origin, right? Because this constraint is less than type, less than and equal to type, right? So this is the direction for first constraint, this is the direction for second, and this area is common to both these constraints, right? So at this point you are getting x1 equal to 12 and x2 is equal to 6, which is the answer for this particular question. So you are making 12 mobiles and 6 laptops, and your total profit is this. A very simple linear programming problem. So this is how you should select any product or any project, right? Let us look at another method of project selection. This is known as integer programming technique. In linear programming, it is possible that you may have a value for x1 as 12.5 or x2 as 6.5, but when we say integer programming, we want our variables to take only integer values, they cannot take fractional values. So, I will take a very simple example and we will try to formulate integer programming model. Let us say there is a company is planning its capital spending for next T periods, and there are n projects and to be completed within limited budget. So, BI is the budget available with the company and there are n projects, and in next couple of T periods we have to select couple of projects, right. So, each project requires a certain investment in each period once it is selected. So, if a project is selected in a particular period, we would have to assign some budget to it. Let Aij be the required investment in project J for period I. Aij is the investment in period I for project J. The value of project is measured in terms of net present value, that is NPV. Let Vj is the NPV of project J, right. Now, the problem is to select the proper project for investment that will maximize total NPV. Little bit difficult, but you should try to formulate a model. So, if you look at this question, your objective is to maximize NPV, right, and you can maximize NPV when you select a project. If you do not select a project, NPV would be 0, right. So, how to prepare a model for this question? Okay, let us do it. This is your question. So, Xj is equal to I if project J is selected, otherwise 0. So, Xj is 0 if project J is not selected, otherwise 1 if it is selected. So, maximize summation of Vj Xj. So, if Xj is equal to, if Xj is some positive number, then there would be some NPV. If it is 0, then this would also be 0, right, and J is ranging from 1 to n because there are n possible, there are n projects available. So, if this is your objective function, then you have got constraint on your budget, right. So, this objective function is subjected to Aij Xj. If Xj is selected, if J is equal to 1, it means that project is selected, and when a project is selected, then this is your what, the budget requirement, right. Aij is the required investment, right. Just see this, Aij be the required investment in project J for period I, right. So, this should be less than or equal to your total budget available, right. And one more constraint is that Xj has to be this, of course, we have already ensured that constraint, that Xj is either 0 or 1, right. So, there is no possibility of having Xj is equal to 1.5 or 3.5 or so on, right. So, this is how you should formulate this integer programming model, right. Now, I will take a very simple example as far as NPV, as far as integer programming is concerned. So, let us say there are 4 projects, this is similar to what we have done in previous slide. So, there are 4 projects, you have got project 1, 2, 3 and 4, and these are the profits. Cash flow in first year is this 60 and 90 for fourth project. Cash flow in second year 160 and 70 for fourth project. Now, You have got two constraints here. Cash flows in first and second year should not exceed 600 and 700 rupees. Project 1 and 3 are mutually exclusive. It means if you are selecting project 1, you cannot select project 3, and if you are selecting project 3, you cannot select project 1, and the company wants to maximize profit, right. So, how would you solve this, or how would you formulate this problem? You have to formulate in a way what we did in this slide, right. Okay, so let us look at how to formulate a model. So, this is 105 x1, 140 x2, 80 x3, 100 x4, subjected to cash flow in first year is what? The budget is this 600, right. So, 60 x1 plus 108 x2, 200 x3, 90 x4 less than or equal to this. The second constraint would be 160 x1, 40 x2, 150 x3 and 70 x4 less than or equal to 700. But you also want to satisfy this particular constraint. So, either you select 1 or 3, right. So, what you should do, x1 plus x3 is equal to 1. So, if you are selecting x1, for example this constraint, if x1 is equal to 1, if you have selected first project, then definitely this would be 0, and when you select x3 this would be 0, right. So, this is how you can formulate model, right. Okay. Now, so far we have seen linear programming as well as integer programming techniques for project selection. In next class we will see couple of multi-criteria decision making techniques for project selection. Thank you very much for watching this video.